We've got an assignment due tomorrow, and then the day off, Monday. Project due Thursday, final exam Friday. Our final exam will be at the normal time on Friday, and we'll have the entire 2 hours to take that rather than just 80 or 90 or 95 minutes. Do you have another question?
We got homework in Tuesday too, don't we?
Oh yeah, this isn't showing all the homework assignments for the rest of the semester, just the one that's next. This afternoon, I intend to give you a little bit more guidance on the project, and it's not that I'm going to be helping you understand it anymore in a direct way, but what I'll do is I'll suggest that you solve the project at certain parts of the project at a fixed flow rate and for a certain diameter. And so I'll have you suggest that you do it by hand so that when you set it up on Excel, you can verify whether your equations in Excel are correct. So I'll either, if when you're working on the in-class exercise, I'll type it up or I'll send it via email this afternoon. So keep your eyes peeled for that. Any questions on the project for those of you who started already? All right. Well, let's get into this good stuff then. So what we've been doing so far is we've been discounting or compounding cash flows at some given interest rate, at the minimum attractive rate of return. And that is like sort of the threshold by which a company decides whether or not it wants to do a project. And so we would discount a cash flow to the present, for example, and find out that at that discount it would either have a positive net value, which means you should go forward with the project because the income is bigger than the expenses when discounting at the minimum rate, or it would be negative, which means don't do the project. But the internal rate of return is the interest rate that would make everything discount to zero at the present. And so it's the way of finding out actually what is the return on your investment. And it makes a couple of assumptions which we'll get at, but you can see from the diagram there that what it means is that the cash flow in and the cash flow out are in balance at the internal rate of return. And so you remember what you did yesterday in the in-class exercise was you used the table method, first of all, to discount everything to the present and find out the net worth of it, and it was positive. And then you set that up with Excel, where you were using the MAR. Well, if you did a goal seek, and you said, instead of discounting everything at the MAR and finding out what the eventual present worth is, if you did goal seek and you said, I want the present worth equal to 0, and you said that you do that by changing the interest rate, this is the interest rate that you find. The internal rate of return is, by definition, the interest rate that will give you everything discounting to 0. And so it should be used when revenues are present and they exceed the costs. You can't have a negative interest rate, a negative internal rate of return. That won't work. And it's used Excel, it's solved easily with Excel, and so I'm going to give you a demonstration of how to do that real quick. So let's use the example of start from scratch. So we need to pay $10,000 in year 0. And then we get $2,000 for 5 years. And a salvage value of $2,000 at the end. So an additional $2,000 on top of our annual revenue. Okay. So previously what we do is we'd have some interest rate, we called it the MAR, and when we yesterday, we'd have the MAR, and if it was 0.05, for example, then our approach would be to find the present value of everything, and then at the end, find the sum of the present value. So we'd use the equals PV formula at the MAR. If this is N, it's not a payment, it's a future value, and we'd use the negative so that the signs are preserved, since present value function automatically flips it. Format it as currency, because I don't like those red numbers. They distract me. Makes me feel something's bad is going to happen. So, oops, didn't anchor the interest rate. And then we sum it up. So this was yesterday. What we did was, if the MAR is 5%, then we get 226 left over beyond the 5% return that we got. And so now what we want to do is we want in goal seek, so data, what if analysis, goal seek, we want that to be 0. And we're going to do it by changing the interest rate. So it turns out that the interest rate that gives us 0, 5.732. And then I'm going to change this because it's no longer called the MAR. MAR was our minimum. What this is the internal rate of return. All right. So it's pretty easy. It combines a couple of skills that you already have, namely using the present value function to discount a cash flow to the present. Already had that skill. Boy, it just is so dim, isn't it? I think that projector is sort of losing its strength. It's becoming weaker and weaker. Let's just go into the menu. The brightness is already turned up. Maybe it needs to be cleaned or something. I'll look for it.
It tells you how long the volts got left on it.
Yeah, well, it tells us how long we've been using it, I think. 675 hours on the filter. I think the filter is supposed to be cleaned. The bulb died last year. Well, that's not any of your concern. That's why you pay tuition, is for a nice bright screen. You're not getting your money's worth. Start a protest. All right, so the skills that this uses is the discounting cash flows to the present using the present value function, summing it up, your equals sum function, long-time favorite, and then goal seek to set the desired sum is 0. And so at 5.732%, that is the internal rate of return. So that's an example that shows the cash flow. Now here's the big assumption. Now this is one of those beautiful test questions. What does the internal rate of return method assume? Assumes the cash flow generated by the project is reinvested at the IRR. What does that mean? Let me show you what it means. Back to the Excel. So the big assumption here is that you made $2,000 in year 1. So this method assumes that that $2,000 that you had as income, you reinvest into the business. You don't put it in your pocket and go spend it, or you don't put it in your pocket and put it in a savings account. This method just sort of inherently assumes, because of the way that discounting works, all of these cash flows are discounted to the present. And so this 1892, that is the value in year 0 of 2,000 in year 1 if it's discounted at this interest rate. Well, the only way for that to work is if it was reinvested at that interest rate. And so it's sort of a little bit of a catch-22 here, is that you're trying to find out how much the project generates in terms of a percentage return, but for that to be true, the cash has to be reinvested in the project at that interest rate. That's not always possible. If you make a one-time investment, this $10,000 investment in year 0, the income that's generated from that may be going to other things later on. It may not be going back into the project. And so that's just something that you should commit to memory, is that cash flow generated by the project isn't always reinvested at the same rate, but this assumes that it is. I guess it doesn't necessarily have to be the same project. It would have to be a project that has exactly the same internal rate of return, because that's the interest rate that it's being discounted at. See, so what do I mean by discounted?
I mean, like moving the future order from the present.
Right. And what's compounding, Josh?
Because when you combine different terms, like here's where together and do the interest thing.
Okay, sort of. The way that Cecil said discounting is taking a future value to the present. And so compounding has a very similar definition, but a little bit different. What's compounding?
Multiple future values to the present.
No?
Take the present to the future.
Taking present cash values to the future, right. And so you compound into the future, you discount from the future into the present. And so when I say that this cash flow is being discounted at the internal rate of return, what we're saying is that $2,000 4 years in the future, the value of that today, here in year 0, is $1,600 if this is the internal rate of return. And so all of this money is being generated, but we don't really know what the value in the present of it is, really, until we have some interest rate. But we solved for the interest rate. You know, that was our goal seek, was we were telling it to change the interest rate around until this equaled 0. And so for this whole cash flow to be true, it means that the cash that's generated is being put into a project that makes this internal rate of return. Sometimes you can reinvest money into your business, and sometimes you can't. Sometimes it's just a one-time investment and there's not room for any further investment.
So you're saying that cash flow is reinvested at what?
At the internal rate of return, which is what we just saw before. So it would either be a savings account that happens to pay the same interest rate as your internal rate of return, or another project that makes the same internal rate of return. Okay, so what this shows is consider what happens when you make an initial investment, how much you're still trying to get back. Unrecovered investment balance. You know, the cash flow diagrams that we've been showing so far, many of them have looked like you make some big investment to begin with, and remember, when it's down here, it's like money out. That's when it's down, and when it's up, it's money in. So the cash flow diagrams that we've done have mostly been an upfront investment that then yields some sort of a revenue in the future. So what this chart is showing is it's a little bit the reverse. Up in this chart is unrecovered investment balance. And so it's how much you've put into the project that you haven't got back yet. So it's how much you have coming back to you. So at the beginning of the project, you made this big payment, and then how much you've got coming back to you is actually going up. But there's a dashed line there. That dashed line sort of means that it's imaginary in a way, because it's only at the end of the year that any real transaction happens. And so why it's going up, that means is that you made an investment, and then during the year, actually, there should be interest on that investment. And so that's what that increase represents, is that when you make an initial investment, time marches on. You're still, even halfway through the year, that initial investment should be worth more. And so you still have more coming back to you. And so in the first year, at the end of the first year, it goes down because there's some sort of a revenue. Then there's still an unrecovered balance that's earning interest, and you get more revenue. More revenue. And eventually, it goes to 0 at the end of the project, if this has all been discounted at the internal rate of return. And so what this diagram shows is that You can think of it another way. You can think of the, remember we saw the cumulative present worth in one of the in-class examples. This is the cumulative outstanding investment over time. And at the internal rate of return, at the end of the project lifespan, it will go to 0. So internal rate of return is the interest rate that causes it to be 0 at the end of the study period, year end. And so let's use this example that I just set up to create a similar type of chart. I'm going to move this over here. All right, so this is going to be unrecovered initial investment. I don't want it to be quite that wide, so here's something I learned when I was freshman, sophomore in college. If you right-click on a cell, format, alignment, wrap, then it makes it so that it stays in the space available. Right. So in my first year, I paid $10,000, and I guess we're thinking of it in the graphical terms here. It was a positive amount. So unrecovered investment balance means it's unrecovered initial investment balance. So it should be a negative number, negative of the present value. Okay, and then at the end of year 1, it was the previous amount minus however much happened that year. And then once I set up year 1, then I can just drag it down the rest of the way. And we'll see what the balance goes to. So at the end of year 5, finally, I've made back all of my money at the internal rate of return. So we can set up a graph of that. It's not going to look exactly the same as the other one because it's not going to be showing the intermediate increases due to the interest over time. That was more of a conceptual graph. Here's a nice thing. Right-click on these grid lines, and you can make them go away. Because they don't really add any value, right? Okay. Any questions about this figure or what it means? So again, to summarize, what we're trying to do is we're trying to find it so that the revenue equals the expenses. What interest rate makes them equal? So we're going to find the present worth of the revenue and expenses, where we're taking all of the future values to the present for both revenues and expenses at some unknown interest rate, I prime. So I prime here means an unknown interest rate. What is the interest rate that causes these things to be in balance? And if we have our interest rate that's more than the internal rate of return, then we'd have a positive present worth at the end. Or if the interest rate is larger, then we'd have a negative. So let's test that relationship with what we've set up on Excel. If we play around with the interest rate, then we're going to so what it said is if we choose less than the IRR, then this sum should be positive. So if we had 4%, then we have a positive amount. That means that at 4% interest, there's more income than expenses. At 6%, then it's negative. So why don't you grab a computer and boot that up. Get a try with the internal rate of return. We're going to work this example together. What is it? While your computer's booting, draw a cash flow diagram in the notes for this problem. By the way, do you like the notes better when they have the lines or there's no lines?
If you're going to draw cash flow lines, cash flow diagram, no
Lines or no lines?
I like lines.
No lines?
I like lines.
You like lines. Okay. So I'll just print 2 sets of notes. One's for those of you who do like lines. When I was in my previous university, I didn't even print the notes for the students. That's how mean I was back then. I thought they should just be taking handwritten notes. Actually, it's better for you. You remember more if you take the notes yourself rather than if they're given to you. But nobody seems to
Don't forget
really
these
believe
tablets,
that.
you could just post them on Blackboard.
What's that?
If you're going to use these tablets in class, you just put them on Blackboard and not print them at all.
Yeah, but if they were on Blackboard, then students wouldn't take notes. They'd think, oh, I'll just look at it later. So draw the cash flow diagram, and then I'll put it up on the board and see if we're on the same page. Always mark the ticks on the x-axis. Don't make me count when I'm grading your quiz or test. Just go ahead and draw it. It doesn't take that much time.
What about this number?
Huh?
Numbering is fine too.
What do you mean?
Like actually, no.
Draw the marks and number them.
Yeah.
Yes.
It says next, after that, so it'd be 12 years.
Yeah, I think that's worded wrong. In each of the 6 years.
That's right.
Because it won't be able to generate revenue after it's been sold.
Well, I didn't say that it's being sold.
It does. It says at the end of 6 years, it's being sold.
Well, I just like it. But you can't blame me for it. Sure, I was born that way. It would hold up. It would.
All right, so set this up as a spreadsheet similar to what I did in the previous example and calculate the internal rate of return. Using goal C. What if analysis?
Oh, it's just,
Go down that much. What? I don't think it'll go down that much.
over 200%.
I didn't put it as percent. Probably.
No, it's 22.05 percent.
I don't know, that percent is 0.22.
Okay, that's not 345,000, that's like 34. It's 340,000 or whatever. Your amount, it's your amount. It's supposed to be. That is zero. Yeah. Yeah. Because your rate. Slow down.
Yeah. Oh my God.
I thought I had a brilliant idea last night. I looked on YouTube.
Why would they do that? That's
They would, why would they do that? So it's 70 funds out.
yeah. It's kind of cool though. Yeah. Where do you play games on? Drop it.
Shoot, someone
That's what she said.
That certainly makes sense. Oh,
It's a nice student.
Yeah, I thought I had a brilliant idea last night. And I looked on YouTube and started using it. You know, like you get tablets, right?
Yeah.
Right. Well, what about taking 2 iPads and like connecting them on a hinge so it's like an actual book? That would be. It's already invented.
Okay, I've got one for you. A restaurant sells only cold pizza and cold stuff like ice cream, cold pizza. Is there cold pizza and ice cream? I don't know.
Okay, you'll notice I set mine up a little bit differently. I've actually separated out the expenses and the revenues rather than combining them. And you don't have to do it that way for this problem, but there are some of the next kind of problems or some of the other methods that would require you to have them separated. And so I'm just sort of showing you that now so that you can get used to that as an idea that the expenses and the revenues would be kept separate rather than combined. Ultimately, for the internal rate of return, you get the same answer. So that is with the the what if analysis. Now, what about the interpolation method? By the interpolation method, what we mean there is if you have the, let's say, what is the interest rate, and then what is the present worth of the project. So if it is 20, 21, 22, 23, and 24, just as an example. So change it, copy down the amount, 19,413. What if it was at 21? 96,15. 22. 235. -8,749. And 24. Okay, so I've just actually put in a couple of different interest rates and found out what the present worth is. We can create a graph with this data that we've just copied down, and where it crosses the intercept is going to be the interest rate that is the internal rate of return. So what we're doing in this is we're recreating this figure. We're going to recreate a curve that shows what is the present worth as the interest rate, the unknown interest rate changes. And so I'm going to insert a chart. So we lucked out that it's actually really close to the 22, but you can see that as we zoom in, well, let me remove those tick marks. A little bit to the right of 22. So we can gather that data just by changing the interest rate. And we note down when we typed in 0.2 for the interest rate, what was the present worth. We sort of key in different interest rates and find out the present worth and create a chart that's similar to what we saw in the notes. I'm not using a trend line for this one. I'm using the smooth scatter chart. So we look at the chart type. Well, right-click chart type. It is this one. Smooth without the data points shown, because the data point happened to be right on the, well, very close to the intercept.
Is there a way to like mark your like x-intercepts on the graph?
What do you mean?
Like, so you can see it on the graph, like.
You have to extend the data.
Well, I mean, not your y-intercept, your x-intercept, like the exact number, like to mark it on just the graph itself.
You could write shapes and do something like a triangle.
Oh, but you can't just put it like a line that automatically know where it's at?
No.
Okay. Fine, so like on my calculator, you just find 0.
Yeah, you could have it generate an equation and set it so that the present worth was equal to 0.
Anyways, I gotta find
I told you open a restaurant.
If I was to open a restaurant, it'd be like
Cold
Texas
pizza.
barbecue.
Cold pizza, cold Should there normally be
Cold
more?
barbecue, that's Texas barbecue. They cook it in the morning, by the time you're ready to eat it, it's stone cold.
Yeah, Are you talking about like room temperature food, or are you talking about
I think
like
so, like
freezer?
I'm
refrigerator
talking
pizza.
about stuff that, you know.
All right, what's the last thing in this example that we need to do? The Excel method of internal rate of return. Well, what does it mean by Excel method? Actually, there's a function equals IRR. So let's see if we can figure out how to use that. It'll prompt us what it wants. And so this is using the IRR function. Okay, so equals IRR, the values. So it wants to know the values. And the guess that it's expecting is optional. That's when it's in bracket like that, that means that you don't necessarily have to provide it with initial guess. 22%. Boy, Excel is smart. So what I highlighted was not the present worth values. I highlighted the actual values in the year that they're in.
So you know like the total values?
Yes.
Alright.
Right.
You can't do it with like the expense revenue method, can you? Can't use this.
We're going to have the expenses and revenue separated when we use the external rate of return. But well, I mean, maybe, I don't know if we highlighted the entire range. IRR, I don't think we could do this, for example.
That's what I was.
Let's see. No. I don't know what it's assuming in that case.
Great. It's kind of weird. You think that would for ad numbers.
That's all it's about.
Not free me.
So nice tools like that are available for you to use, like to check your work, or when you're out of this class. But use the real way. Don't just like hand in your homework and write, I did IRR method. You know, like I don't consider that really practicing. You have to understand how it works before you can use the automated tools. That's my point. And the reason why is that sometimes the automated tools, if you misapply them, will give you the wrong answer, and you have to be able to figure out why it was the answer that you weren't expecting. So any questions about this example? We tried it a couple of different ways. We found the present worth individually, then did goal seek. The interpolation method was where you graphically constructed the chart of interest rate as a function of present worth, and then equals IRR. So Excel method, what we meant by that is to say equals IRR. All right, external rate of return. Remember, our assumption from the internal rate of return is that all of the cash flows are being discounted to the present based on the assumption that the money can be reinvested at the IRR. So if you have a housing complex that's yielding you a 5% return, it's not always possible to take whatever your income is from that and put it right back into the housing complex. There are going to be times when you just have to put your revenue into a savings account. And it's possible that your savings account isn't going to, by some strange coincidence, yield the same exact rate of return as the project that cash came from. And so external rate of return is a way of accounting for the fact that sometimes the money that you get is put somewhere else, and the rate of return in that somewhere else location is different from the rate at which the cash flow is being generated. So this is got some unfortunate variable definitions, and you're going to have to be really careful here over the next 3 or 4 minutes to understand the difference between these variables, because they sound alike and they look alike, but they mean hugely different things. So the first variable is external reinvestment rate, E, epsilon. That little symbol there looks like a weird cursive italic E, epsilon. That is the interest rate. You can write this down in your notes. This is that savings account that all the cash gets put into. It's the money that is being reinvested somewhere. It is the rate that it is saved at. So if you owned a housing complex and all of your revenues went into a CD, then the interest rate from the CD, that's your external reinvestment rate. Now look what it's not saying. It's not saying external rate of return. And this is why I think it's kind of unfortunate that the words are so similar. External reinvestment interest rate is different from the external rate of return. We haven't yet got to the external rate of return. This is just one of the pieces, external reinvestment interest rate. And the other unfortunate thing is that ERR, maybe you think that means external reinvestment rate. No, it means external rate of return. So flashcards, use the Andrew Canterbury method for getting all of these variables straight, because it's important that you know what's what. Okay, so epsilon is the rate that the generated cash flow can be reinvested. So what we're going to do in this method is we're going to, the money that goes out are going to be discounted to the present using the external reinvestment rate, epsilon. The inflows are compounded into the future using the external reinvestment rate. And then the external rate of return is the interest rate that makes them equal. So it's sort of like doing the internal rate of return approach of solving for some unknown interest rate, and you're wanting to find balance. So graphically, let me show you what I mean. In a typical project, remember that we make some initial investment, and then maybe there's maintenance along the way. You know, we're paying every year a little bit of maintenance. And maybe there's a major refurbishment in one of these years. And then it's generating cash. And then it's also sold. This is the salvage. And so, you know, this is initial investment, refurbishment, annual expenses, income, salvage. So what it's saying is the first thing to do is the net cash outflows are discounted to times 0. So what years? 1, 2, 3, 4, 5, 6, 7. What years do we have net cash outflows? Net cash outflows.
All 7.
What net means is when you consider the revenue and the revenue and the costs together. So what years do we have net cash outflows?
1, 2, 3, 5, 6, 7.
Just 0 and 4. The net outflows. And so, because this is bigger, these lines are bigger, that means that we're getting more money in. There's more income years 1, 2, 3, 5, 6, and 7. And so the outflows is when you're losing money. So we take year 4 to 0, and so what we'd end up with is some money, our outflows would be at the present, all of your income would be compounded to n, so this is out, this is in, anytime we're above the line. So we take all of the positive cash flows to the future, all of the negative cash flows, the net negative, to the present, and then we would solve for, and we would do that at epsilon. So discount / compound at the external reinvestment rate. And then now when we have the net outflow at present, and then the net income at future, the external rate of return is the one that makes these two equivalent. And so you would do the same thing that we just did with the internal rate of return. You'd set up a cash flow diagram, you would discount this, to the present, and you'd solve for the interest rate at which all of those future revenues are equal to the present expenses. Yes?
Could we take you're saying the epsilon percent, just, that's it, value, just anything you want?
No, it's the interest rate that you'll actually be able to reinvest the money at.
Okay.
And so it's not an unknown. It's usually a given.
Okay.
It would be, a bank account rate or a CD, something that's fixed. And then the unknown will be ERR, external rate of return. So here's a formula that shows how it all fits together. The sum of all of the expenses taken to the present. This is how to read this. All of the expenses, you take all the expenses to the present at the external reinvestment rate. Then the sum of all of that is going to have to equal, when you take all of the revenues to the future, when the unknown external rate of return is the one that brings them into balance. And so you have to either find the future value of the expenses or the present value of all the revenues, either one. In this case, what they're showing is that once you sum up all of the expenses at the present, then take all of those from the present to the future. It could also be the other way around. It could be that we take all of the expenses to the future or all of the revenues to the present. It's going to be the same unknown interest rate, I prime, that is the external rate of return. So here's a diagram that shows conceptually what you're doing. The expenses go to the present, revenue goes to the future, and you move them there at epsilon, and then you solve for I prime, which is the external rate of return, the one that brings them into balance. Okay, so here's an example, and you can go through it as I type it. We want to find out the internal rate of return, and then we're going to find out what's the external rate of return for this project. So I'm just going to highlight this and copy it over. You can't do that. You're going to have to type it in. Okay. So if I wanted to find the internal rate of return equals IRR, or I guess I could do it the not lazy way, present value. And here's my IRR. You have to go into insert
Oh,
symbol.
symbol.
Yeah.
Oh, we're in Greek. It's in Greek. It's Greek and Coptic.
So what I'm doing is I'm finding the present worth of the expenses. Anytime there is a negative in the year, the net negative, I find the present worth of that. Oh, it's the future worth I'm supposed to find of the incomes. So FV of the revenue. So equals FV. Oh, and here's the tricky thing about N, is that what I'm going to have to use as N here isn't just going to be whatever year it is. It's going to be 7 minus whatever year it is, because of how far away it is from the point that I am taking it to. And so what I mean by that is the amount that's in year 1, I have to move it. If everything's ending in year 7, I have to take it 1, 2, 3, 4, 5, 6 years. And so it's going to be 7 minus n as the formula that I put in for n. Because if I said let it be n, then it would just take it 1 year. And that's not far enough.
Are you taking, for the future value, are you taking the interest rate?
I'm using epsilon.
Oh, you're using that?
Uh-huh.
Gotcha. What is
There's something new right in here, where I'm saying 7 minus n for the number of years that's going on for the future value. How do I know it's working correctly? Well, what is the future worth of $5,500 in year 7? It should be still $5,500. So that's how I know that this function is working correctly. Is it's taking money, cash flow from year 1, it's taken to year 7. And so we're compounding it to the future.
Where did you? Where did I screw up that?
No. We're never using the internal rate of return on this ERR part. Yeah, that's fine. Anchor it. And for n, it's just that, you know.
The future value is this.
Negative.
Well, it's just gonna go on forever. Then this one's gonna, well, you simply pull it down.
So let's, something that's probably 19 number ones.
Oh, I got you. Oh, that's probably what.
I think it's right. 37. Yeah.
It's big. Big that. So it's 7 minus.
Oh, I know, it's just 2.5, no, percent.
So I have to emphasize that there's a big line here between these two parts of the problem. Nothing on the right side comes from the left side except for like the cash flow. I'm not using the internal rate of return. So then the last part, the external rate of return, is I need to find out what is the interest rate that will make these two equal. So I'm going to have another interest rate I prime, and then put in some guess here, maybe 0.02. I don't know what it is because I'm going to do a goal seek on it. And so what is the okay, so the present value
What's the right answer for the ENGR?
5.22%. Let me write it one more way just to make it a little bit more neat than maybe it was previously. So here's our cash flow.
Just one more thing out here.
Walk it right.
That does not look right. Okay. Okay. Okay, cancel. Okay. No.
Certain interest rate. What's your EDD?
That's what I wondered.
Some number. Shoot E equals 1,000.
Epsilon.
Yeah, you should make E epsilon equal. So what if this equals 0? Something equals 0. Changing set. Do you have a PD? Let me see, put on that. Let me see, put on that. That's all right.
It's supposed to be the sum of this.
Go to one. Go to E first. I'm sorry, PD of that. PD of that. I'm walking it. Space. Year. 0. Okay.
Wouldn't it be at your seven?
Yeah, that's all we need. Get a lot.
So, how's your day?
You're
All right.
What this-
I was doing good. I was
Yes.
Now I want to
Equal sum, mark. Equal sum.
that will, now I want to make this.
whichever. You can take this.
Say you want this class for
Let's go for it.
Hey, so you want to see the sum of $7?
I don't know. Maybe it's because you get zero.
Huh?
Maybe it's because you get zero. Why is your sum $7 on?
The top, yeah, right there.
Yeah.
Because I was playing right with it manually. I
Oh,
didn't
okay.
actually use the what if analysis.
Were we not supposed to use what if?
Oh, you certainly can.
Okay.
I was just playing for fun.
I don't understand what I did.
That's good.
Need to save this.
Once you finish this, go ahead and take a quick break. We'll have 5 minutes to get a drink of water. I'll circulate around during the break.
The snap machines, the doors, like, halfway open. I don't know, they're still the same.
You start off with a guess. Maybe it's 0.01. And now, you need to have the sum of the expenses and the sum of the revenues. What? Okay.
Yeah.
Okay, great. So now do the what if analysis.
Let's go with this one,
Uh,
sure.
Yeah.
Where do you go? Came over here, just go up.
We'll see. Your goal is that you want that sum to be zero, right? Maybe, by changing. No, how are you doing that? So it might be- Let's, instead of saying for it to be equal to zero, I want to make sure that both of these are using referencing. Okay, so our, okay, no, it's not supposed to just be the sum. You're supposed to find the future, the present value of that at that rate. So it's actually, you're moving it. You're not just adding them together. You're converting it from the future. So equals PV and refer to that rate. Because that sum wasn't using that rate. Okay, for n is 7. They're 7 years apart. So you're taking that, yes, so that's your future value. That's not. No, it's okay. It's all right because you're just going to look and see. Okay, so at that rate, you're taking that future amount to your zero,
that's how much it's worth. So what you want to do now, is change that so that this is equal to negative 25,928. Yeah. Changing. There you go. We got it.
Okay, so just to refresh our memory of the outline of steps here, you discount expenses to the present using epsilon interest rate, compound the revenues to the future using epsilon, and then
You need to, you need your, where's your revenue?
discount the future.
I thought that was it.
Yeah. You need to right here. You need that. This right here, in your statement. Rate, changing the rate right there. That one. Comma. No, go down to 7. Oh, way over there.
Okay.
And then you go to comma, and then you go to negative. That right there.
And negative this one.
No,
That
the
one.
one button below it.
Oh.
Then you do your fancy goals.
Then
You hit the sum of buttons. Sum.
Oh, okay. Just confusing. It's not that.
And then you go to goals.
If I were you, I'd write this down. Writing down the steps may help you crystallize in your mind what you did on Excel. And after you write down that little paragraph, phrase, steps thing, I'm going to go through the spreadsheet and show how we followed it.
Oh yeah, I need somebody's flash drive. I have to put this on my laptop.
I got one. I think so.
Got it right
I still have homework before to fuck up on my class.
Didn't I give somebody my extra flash drive? Like Josh, I think I gave it to you.
Dude, I lose flash drives all the time.
Last time I gave you.
I've lost like 9 of them. At least I haven't lost your phone drive yet.
You better not, you're not allowed to touch my phone drive anymore. I think I got like the seven. Pretty well done. I'm gonna do this for 3 and I'll get you back in time.
Well, well, look, this you learn more
That's
this way.
right. Okay, here we go. This equals present value of this dashboard. We don't do anything with what equals anything. Originally, what am I calling this? What, no, I didn't. Have we done it right?
That's the smoothest thumb drive ever.
It is pretty flash.
You can't be an actual thumb. What else are we doing that right there? Oh, this is it. Payback period.
Didn't change. Now this one would be equals. Right? I don't know why I didn't want to do it last time. There you go. 7, you should want 7.
I actually used this method a couple of months ago to help me decide whether or not I should buy an investment property. And because I knew that whatever revenue was generated, I wouldn't put back into the property. I would be putting it back into a savings account. So I wanted to know, is it worth all the trouble of being a landlord? What kind of interest rate would I get on my investment?
My uncle hates being a landlord.
Slumlord.
Yeah. I decided ultimately not to do it because I was getting actually a really nice rate of return. The external rate of return, which takes into account, basically what the external rate of return takes into account, it accounts for not only the rate the cash is being generated, but also it takes into account what you're reinvesting it at. I had a good return, but it's just that it wasn't on enough money. You can buy a house for 20% down, but as cheap as houses are around here, it was just sort of like a lot of work. I could make like 9% interest on a small investment. 9% is way better than a bank account, but a bank account you can put an unlimited amount of money into it, and it takes no work. So. All right, let me show you, just in summary, on both of the different ways how I followed these steps. Okay, so up at the top, which is I think the pattern that many of you followed. So first I found the internal rate of return just for practice, right? I did the IRR method. I took the present value of everything and solved for the IRR that would make it 0. Okay. Now I'm going to blank that out so that we don't even think about it. Sorry. Okay, so now for the rest of this solution, what I'm doing is I've got a certain cash flow, that's the given, and also the given is the external reinvestment rate. So I find the present value of the expenses at epsilon. So discount expenses to the present. Use epsilon. Step 1. This is step 1 right here. It only applies to 2 years because those are only the 2 years that I had a negative net cash flow. So I took them to the present. So the sum of my presents, I can put it down here, equals sum. The sum of the present value of the expenses is negative $25,929. That's the same as over here. All right, then step 2, compound revenues to the future. Use epsilon. So this column is where I'm taking, anytime there was a positive net cash flow, I'm taking it to year 7. So the value of $5,500 paid in now in year 7, well, if it goes into account and it earns interest, if I put $5,500 into a bank account in year 1, by the time it gets to year 7, it will be worth $63.78 if that bank account was 2.5%. So that's like the physical interpretation of these numbers. $6,500 in year 2, by the time I get to year 7, it's worth $73.54, and so on. So I can find the sum of all of those. This is how much all of that is worth in year 7. It's $37,032. So the reason why I've done the sums here is to sort of emphasize where that money is at. All of the revenues have been taken to the end of year 7. All of the expenses are at 0. Is everybody with me so far? We've done steps 1 and 2. Discount expense to the present. That's this. All of the revenues went to the future. And the interest rate I used for both was epsilon. Now step 3. Discount the future revenue. Discount that to the present using the unknown interest rate I prime. And so I don't know what it is to begin with, so I've got some guess, 0.01 maybe, 1%. So if you convert this future revenue, I take it from year 7 to year 0, what interest rate does it take so that it balances out the investment that is in year 0? And so I'm going to play around so that maybe I've got a difference equals difference equals that plus that. So this tells me how far off I am. 0.02, getting closer. 0.03, getting closer. 0.04. So I am discounting that future revenue to the present at a certain interest rate. And when I goal seek it, I want the difference to be 0 by changing, and then this is external rate of return, ERR. Any questions about that procedure?
What step does summing, that's step 3, I guess,
What?
where you're summing?
This column?
Yeah. That's step 2.
Well, that is just a visual representation of, it's step 1 and step 2, because discount expenses to the present. So this is where I discounted each year individually to the present, and then sum is, I've taken the sum of all the individual years to the present. This column is step 2, compound revenue to the future, so it's the individual years compounded to the future, and then in the sum, I've added them all together. So it's still step 1 and step 2 in this column.
Yeah, so you'll always have your expenses and your present value and your revenue and your future value.
That's right. And then step 3, I changed around the interest rate until I found out how is the revenue in the future balanced out by the costs in the present. So just the other way I presented that, so that it's maybe more compact. Here's my cash flow. I found the present value of the outflow or the expenses, the future value of the revenue, same as the thing above it, and both of those were at the external reinvestment rate. Sum them up, and then I'm converting the inflows that are at the future. I'm going to take the present value at the unknown interest rate down here, external rate of return. And so I play around with that until the this amount converted to the present is equal to the outflows of the present. Don't worry, you have more opportunities to practice this. And I'm going to give you that in just a moment after I show you one final slide from today's lecture notes. And that is the payback period method. This is basically the same as that cumulative unrecovered investment chart from before. So this chart that shows the unrecovered investment balance, when you finally cross the line, that's when you found the payback period. You found how long it takes to pay off a project by when you finally have made back all of your initial investment. So in the payback period, you can think of it in terms of how risky a project is, how long it takes to pay it back, because you may have the market change if it's a really long payback period, or your equipment could go out of warranty if it's a really long payback period. Think about it, if you were starting a business to mow lawns, and the only way that your model made sense is if you assumed that your mowers were going to last for 10 years and that they weren't going to require any maintenance. I mean, that would be a really risky bet that those mowers were going to be able to last for so long. And so when you assume that you want a certain rate of return, if you discounted a project using the MAR and then create a cumulative unrecovered investment balance figure, then you find out where it crosses the axis, and that's how long the payback period is. And so you want as short a payback period as possible. You want your money as quick as you can get it back. All right, here's today's in-class exercise. You've seen this cash flow before. And in fact, if you saved this cash flow yesterday, then you can just open your file from yesterday and use that as a starting point I want you to go through and calculate all the things that we've talked about today, the internal rate of return and the external rate of return.